Welcome to Chapter 1, Section 5, the greatest common factor. The Common Core standard we'll be working on during this lesson is finding the greatest common factor of two whole numbers less than or equal to 100. We will also be working on identifying parts of an expression using mathematical terms. Factors that are shared by two or more numbers are called common factors. The greatest of the common factors is called the greatest common factor. We will abbreviate this using GCF. There's a couple ways you can find the greatest common factor. Example 1 is going to show you the first way, and that's just by listing out the factor pairs. So we need to find the greatest common factor of 24 and 40. What we need to do is list the factors of each number. So if we go through and figure out our factors of 24, we know that 1 is a factor, and 1 times 24 equals 24. I like to list these in order from smallest to greatest, so it makes it easier to read and help me stay organized. Then I can move on to 2. 2 goes into 24, and we know it goes in there 12 times. We know that 3 times 8 equals 24, so we can do that. Move on to 4 times 6 equals 24. 5 does not go into 25. And then we get back to 6, which we already have. So we have all the factors of 24 here. And now we need to find the factors of 40. So we have 1, our freebie, times 40. I'm going to try and make these a little bit smaller. 2 times 20. 3 does not go into 40. We have 4. 4 times 10. 5 times 8. 6 does not go into 40. 7 does not go into 40. And we're back at 8. So we have all of our factor pairs. Now we need to circle which ones are in common. So what numbers are on both lists? So 1 is common. 2 is in common. We don't have 3 on both. We have 4 on both lists. 5 is not on both. 6 is not. We have 8 on both lists. Not 10, 20, 24, 40. Okay. So we've circled all of the common factors. Now to identify our greatest common factor, it's just the biggest number that we have circled. So our greatest common factor here equals 8, because that's the biggest number that we circled. All right. Now I want you to go ahead and try and find the greatest common factor of 36 and 54 using the strategy that we just learned. Alrighty. Example 2 is going to start a new strategy. It is going to find the greatest common factor using the prime factorization and factor trees that we learned in section 4. Another way that we can find the greatest common factor is by using our prime factors, because the greatest common factor is the product of the common prime factors that we have. And hopefully that will make sense as we go on here and have an example. So we're going to find the greatest common factor of 12 and 56. All right, so first you're going to create a factor tree for both numbers. So I will do 3 times 4. I know this is prime. And 4 I'm going to break apart into 2 and 2. Circle those. So I have 3 times 2 times 2. Or you can write it with exponents. Now I'm going to break apart 56. I'm going to break that into 7 times 8. I know that 7 is prime, so I'm going to circle it. And we have 2 times 4 and 2 times 2. So I have 2 times 2 times 2 times 7. Okay, so make a factor tree. We did that. We'll write the prime factorization. Now we're going to circle the common primes. So there's no 3 here. We have a common 2 and a common 2. We have another common 2 and another common 2. We don't have a third 2 over here, so we cannot circle this, and we do not have a 7. Okay, so now we need to find the product of the common primes. So what we circled, we need to multiply. So we have 2 times 2 equals 4. So our greatest common factor is 4. All right, now you have another example from the video that I would like you to go ahead and pause the video and see if you can solve these. Using the factor tree and prime factorization method, find the greatest common factor of 40 and 48. Alrighty, go ahead and complete these 4 on your own questions as well. Pause the video, and then when you're ready, come back and I will move on to example 3. Example 3 is finding 2 numbers with a given greatest common factor. So for example, they might give you the question, which pair of numbers has a greatest common factor of 15? And they might give you a couple different options here. Well, if we think about our greatest common factor of 15, that means 15 has to go into both numbers. Well, 15 cannot go into 10 because 15 is bigger than 10. So we know that we can automatically eliminate choice A because it doesn't make sense. Okay, it could go into 30, it could go into 60. 15 cannot go into 21. So we can automatically eliminate choice C. So we've already taken 2 answers out, and now we have a 50-50 chance of getting it right. So now we have to choose between B and D. So what we're going to do here is list the factors for both numbers in B and both numbers in D. All right, so our factors of 30, we know that we have 1 and 30, 2 times 15, 3 times 10, 4 does not go in there, 5 times 6, 6 times 5, and then we start repeating. Okay, we're going to do the same thing for 60. We have 1 times 60. We know that we have 2 times 30. We have 3 times 20. 4 times 15. 5 times 12. And 6 times 10. All right, so then we need to go ahead and circle the ones that are in common. So we have 1 here, 2 is on both lists, 3 is on both lists, 5 is on both, 6 is on both, 10 is on both, not 12, 15 is on both, and 30 is on both. So the greatest common factor for these two, for 30 and 60, is 30. So we know that that's not 15, so we're pretty sure it's choice D, but we're going to go ahead and make sure by doing the same strategy we did for B. So our factors of 45 are 1 and 45, 3 times 15, and 5 times 9. This is why knowing your multiplication facts are so important. And the factors of 75, we know we have 1 times 75, 3 times 25, think of quarters there, 5 times 15, and that is the last one. So if we circle all the ones that are in common, 1, 3, 5, 15, we see that our greatest common factor equals 15 here. So our final answer would be choice D. Right, we're going to move on to example 4, which is a real-life application problem. And it says, you are filling piñatas for your sister's birthday party. The list shows the gifts you are putting into the piñatas. You have identical groups of gifts in each piñata with no gifts left over. How many piñatas? What is the greatest number that we can make? So we have 18 bottles of nail polish, 24 pairs of earrings, and 42 lollipops. So where you need to find the greatest common factor of the number of gifts that we can make of piñatas. All right, so now we have 3 different numbers. It works out the same way that we've been doing it, but instead of having 2 lists of numbers, we're going to have 3 lists of numbers. Okay, so we're going to use the factor tree method here. So we're going to do a factor tree and find the prime factorization of each number. So I know that 3 times 6 equals 18, and 3 times 2 equals 6. So my prime factorization here is 3 times 3 times 2. Okay, then I'm going to move on to 24, make a factor tree. I have 2 times 12, 4 times 3, and 2 times 2. So here I have 2 times 2 times 2 times 3. And last I need to make a factor tree for 42. So 6 times 7, 3 times 2. So I have 3 times 2 times 7. Okay? Now we have to circle what is common on all of the prime factorizations. So I have a 3 here, a 3 here, and a 3 here. I don't have another 3 here, so I'm not going to circle that. I have a 2, a 2, and a 2, and that is everything that I have in common. Remember, then we multiply what we have in circles. So I have a 3 in circles, and I have a 2 in circles. We're going to multiply 3 times 2 is 6. So our greatest common factor here equals 6. So we can make 6 piñatas. All right, we covered a lot in this section, so any questions you have, go ahead and jot them down. I don't have any more on your own problems for this, but we will be practicing it quite a bit going forward. Make sure you write down any notes you have and take some time to ask those questions tomorrow in class.